This is Ronald with Win911, and thank you for joining us for our next installation of our How To Instructional video series. This is video number 10, and I've got Mike Rose with me, and he's going to go over how to configure and set up iFix with Win911. All right, here we go.
So without further delay, this is my environment here. I have iFix version 5.8 set up and running, as well as the latest release of Win911. We're going to talk specifically about the iFix connection and how to get that thing going. So we'll just drill right into alarming and then iFix. And this is our environment. We'll start at the top and we'll work our way down. So squaring away some of the connection issues. So in order to communicate with iFix, we have to have a runtime executable launched, and it has to be launched by iFix. We also need something called the alarm user queue. The two of those things run in tandem to give us updates on the alarm information, as well as the values and whether the alarm has been acknowledged or not. If you're unsure about that, we have a Learn More pull down that will give you step by step on exactly how to set that up, so you really don't need to go back into the documentation. It's here with a click. So this requires us to go into iFix itself and the SCU, the system configuration. Go configure, and then tasks, file name. We're going to have to chase up two files. The first one will be the ALM user queue, which you'll find in the Win911 software. That's in the program files x86, Win911 software, Win911 enterprise, and then there's an iFix folder. And at the bottom you'll see ALM user queue. This is actually an iFix product, but we just wanted to make everything easy to find in the same location. So these are the two modules that you'll have iFix start for us. So we'll start with ALM user queue, and we need two command line arguments to go with that. We're going to name it Win911, all caps, and we're going to specify a size of 6,000. And we'll let that run in the background, and we'll add it to what's being started up, and then we'll go back and get that other, what we call the Win911 runtime executable. So we back up to program files, Win911 software, iFix. Unlike the first one, this one doesn't need any command line arguments. We can just add it as is on the bottom. That all looks good, so we'll save that. Now whenever I start up iFix, it will in turn start up those executables, so you don't have to worry about it. So here's where we specify the name. You remember we set that for in the command line argument. We named the queue Win911, and that's where our software has to be synced up exactly with what iFix is expecting. You can set up your iFix to run with credentials. If you need some more validation on who's interfacing and acknowledging, just click this button and enter your username and password here. I'm going to keep it simple and not worry about that. We also have an ignore comm alarms. They can be alarms you're interested in, but they can also be nuisance alarms. So in this case, I'm going to say they're nuisance alarms and cut down on the spectrum of things we're going to look at. So that's the source tab. Now you'll notice I can maneuver away from that tab and come back to it. Everything is the way I left it. However, it's not been saved yet. So if I were to close the browser down, without saving it, I'd lose that information. So make sure you save it before you're done. Next tab over are what we call health alarms, and it's here to watch the connection of Win911 to iFix. If we lose that connection, we can send off a call list of people we want to notify that we have some problems either with the queue misreading or some other sort of communication error between Win911 and iFix. So the strategy, this is our call out list. This is the people that we notify. I created a few people, backing up just a little bit, I created some email connections, a guy named Adam and a guy named Bob, and I assigned them to a call out list called Alert Floor Operators. And there's Adam and there's Bob, and they are assigned to a strategy called Alert Floor Operators. So these are going to be the guys I'm going to work with. So going back here, I'm going to want to use that strategy, that call out list. So I'm going to select floor operators, give it a severity of 500. Might crank that up a little bit since we want to make sure we're able to get to our alarms. So I'll put that at 800. And I can assign labels. Labels are organizing tools. They're strictly optional. You don't have to use them, but they're real handy, and you can have as many. You can create your own. These are the what we have canned. We call them our canned labels. So I'm going to give this a safety label. And I'll just give the operator a little more information when he receives the message. So next tab over are filters. We have two ways of accessing information, the alarm information. We can use filters, where we tell iFix the types of alarms we're interested in. We can put a bracket around the severity level or some aspect of the tag name, and we'll be fed those during runtime. These are what we recommend as a general rule because they're a lot easier to maintain. You don't have to import a large database or make changes whenever you make a minor change to the tag over in the tag name database. But we do support blocks as well. And the advantage of using blocks is that we can get value information as well as alarm information. If you use the filters, you're only going to get the alarms. If you want to know what the value is, let's say you have a high level alarm, and you need to know that particular high level is, say, 10 feet, then the block is what you'll want to use. So we'll start out with filters since they come up first. Filters, the first thing that defaults when you hit the plus button is our wildcard catch-all called all alarms. You could hit the save button right here, and Win911 would go live, and any alarm that occurs over an iFix is going to be dispatched to whoever's in our default call-out list. But that's no fun. Let's make it a little more, let's close our window down a little bit. So I'll click the down arrow, and I've got two fields that I can use to specify the type of alarm that I'm interested in. I can use either areas or block names. It defaults to all areas and all block names, but I can make things a little more specific by clicking over here, and I've got two options on my definition string. I can use a wildcard or a regular expression. So wildcard is probably the easiest to understand, but the asterisk basically means anything, followed by, let's say, the word tank. This filter will catch any alarm that has the word tank at the end of it. We also support regular expressions, and that's much more complicated and a little beyond the scope of this video, so I'm going to leave it at that. You can add more strings to this if you like, and they'll be these strings will be OR'd together. In other words, I can have let's see, tank and pump. In this case, any alarm that has either ends in tank or ends in pump will be caught by this filter. I'm going to keep it simple and get rid of that second one by selecting it and hit the trash button. Away it goes. Areas are also something that I can make more specific. I can use the wildcard, and of course I have to set up my areas. Like let's see, it's an A through P. Let's say I'm interested in area A. At this point, anything that's assigned to area A and ends in tank will be caught by this filter. I can throw in a label if I want. Let's say this filter is looking for things going on in building 2. So here's my first. What I'll make one more change, and that is the default strategy. Default basically is call everybody, and I want to use the call out list that I created. So alert floor operators. All right, so now I have a single filter.
And Mike, can I pop in for a second? So if you guys have watched the previous videos, we set up and configure things left to right. So what Mike's doing there is tying that to a strategy, which has already been tied to a tactic, which has already been tied to your preferred contacts for that tactic. So you've done it left to right. At this point, you're now tying everything you've done to the alarm. So when that alarm comes in, it knows what course of action to take when the alarm event happens. Sorry, Mike. Thanks.
Not a problem. So you can have as many of these filters as your end user requires. Likely there'll be several. So just keep adding them with the add button. The filters are evaluated from top to bottom. So the first filter that catches the alarm that has the specifications that fit a particular filter, that filter is going to dispatch the alarm, and it's not going to make it to any of the filters that lie below. So I will throw in a second filter. This is the all alarms, and I could leave it there on top, but that's going to catch everything, and the second filter will never see any action. So I'm going to select the top one, move him down, and now I've got something that's a little more logically sensible. The first filter will be looking specifically for the building 2 alarms that have the word tank in it, and if that alarm doesn't match this filter, it'll be dispatched by the filter below, and it'll send that message out to everybody. So I can stack these as high as I want. There's no limit to the number of filters that I can have, and that pretty much takes care of filters for us. We'll move on to our watchdog alarms. Watchdogs are put up to observe our connection with iFix. Basically, when I'm on one, sits back and lets iFix do all the work with regards to evaluating the alarms. It polls the I/O, it compares it to the set points, and it flags the alarms. And then it advises us if an alarm occurs. When I'm on one, doesn't do any polling. We just sit back and wait for iFix to tap us on the shoulder and say, hey, look, we've got an alarm. Well, what happens if iFix crashes? In that situation, we just think that iFix is out there and nothing's going on. So we came up with a watchdog, which is a tag that's guaranteed to change within a certain period of time. That way we'll be continuously getting updates. We really don't care what that value is, or whether it's an alarm or not. The only thing we care about is that it changes within a certain period of time, kind of like a heartbeat. So I'm going to call this heartbeat, and if we lose it, if a specified timeout elapses without an update, then we flag a watchdog alarm, basically to let the operators know that it appears that our skate has crashed. So 90 seconds is the default. It doesn't have to be that. You can narrow it down to 30 seconds or whatever you're comfortable with. It'll probably be, I would recommend 90 seconds just because you probably have more pressing alarms that you're updating at a faster rate. So 90 seconds is probably a good enough time period to keep a sharp eye out on the health. It'll need a node name. This is the fixed node name, which is in this case is actually fix. It doesn't want to read that, so I'll just have to enter it. And there's going to be a tag somewhere in my database called about PLC 5. I'll leave that. I'll leave the 60 seconds as the timeout, and the default is the notify everybody, which is good, and we'll crank that on up to absolute maximum 1000 severity. And you can have as many of these watchdogs. You can have watchdog look at a particular device that's behind the SCADA. If you want to monitor an actual PLC, if that's gone down or not, you can do that using watchdogs, as well as a system parameter like $seconds, just to look directly at iFix itself.
And Mike, how would they utilize the labels with the watchdogs?
It's more or less just it's just an organizing tool. So they would just see a color, and they would know, preferably, if they see this color and this word, that they think that iFix has gone down. There are advanced tactics that can focus on labels and make a decision on what to do depending on the label that it's wearing. But for the most part, it's just an identification marking. So that brings us to the end of the sources section. We'll go ahead and save this. And now we've gone live. So once you save that, whatever you've got entered in is now operational. So if iFix were to throw an alarm, we would email Bob and Adam. So there's the block section where we look at specific blocks, specific tag names. And what we'll do is we're going to jump over to imports, and imports will read our database, and we can bring blocks in based on that. So jumping to import, let me make sure I have this saved, and I should probably run it. Any moment now, see, may have seen it flash by, but there was an indication here that it was that the iFix started the ALM user queue, as well as the Win911 runtime executable. So now we have a database that we can use to import. So going back to Win911, strange thing you have to do. It may seem that way anyway. Before you conduct an import, is you have to have a specifically modified custom strategy set up, and that's a guarantee that once you hit the save button, everything, if it goes straight into your default, if it's assigned straight to your default strategy, then we'll immediately start dispatching alarms based on that, and that may not be what you want to do. You can get into a lot of trouble by doing a large import and then just arbitrarily assigning them to the default. So you can actually use the default. We don't care, but we decide as a safety precaution to make sure that you have at least one non-default strategy set up. So we've met this. Now we've got to decide where we want to go to find the data points we're interested in. You can select the local node that Win911 is on, or you can decide to search your entire network and look for different databases. That's great if that's what you want to do, but we only want to look at local stuff, and the all nodes can take a while to finish querying the network. So we're going to specify the one that's on our machine, which is iFix. And here's some additional information you can include that Win911 will use to describe the alarm. There's a block type, including whether the alarm is enabled or whether it's just a value. And then there's a description. We'll go ahead and grab all of those. And now we should be ready to click the next button. So at this point, when I'm on one read our PDB database, and these are all the tags that I have available to me to import. It's only going to show the ones that Win911 can import. So you may have a much larger database, but if it doesn't show up here, it's because Win911 has no way of monitoring it. It's a strange, it's a strange block. So we'll go ahead and let's just grab everything. You can do that by clicking the top button, and if I hit the add, it's going to move that entire section over to the import side. That may be too much to look at though, so we'll move these back and just grab a few. I want to look at the door, I want to look at the chiller, I want to look at the boiler. Oops. And hopper number 1, hopper number 2. Okay, that looks like a good start to my database, so I will leave it at that. I'll click the finish, and this is our progress, which is already done. So that's good. We can go back and import more things, or we can be done with it. I'm going to be done. Go to blocks, and here are the points that I just imported. We'll take a look at those by click boiler. It's set up to the do not notify strategy. I want to change that to alert floor operators. I have an alarm states. As it stands, this block will call out if an alarm occurs. It may not have a good description though with the alarm, so you may want Win911 to react to specific alarms or give it a different description. So if that's the case, you can go over to the states, hit the add button, and pick a state of the alarm, like let's say a high alarm, and I want to describe that as way too hot, and attach a particular label to it. So description with this set, I'm going to use whatever I'm fed during runtime. If that differs from what shows up from the import, then we will ignore it and use what comes from fix. Otherwise, we'll use the specify, and that ignores what comes from iFix with what we have entered for the description. I can add labels to the block itself. This is for reports. If I'm just interested in a value, then we will attach either a value or an alarm. Really would attach the area. This other tag is only going to be attached to it if it's a high alarm. So I'll save that. And the last thing I want to take a look at, if we're all still good, is reporting. This is one of the data sources. We have several. Some of them don't support reporting or don't support data. Win911 primarily is an alarm reporting mechanism, but we can be used in certain situations to send data out as well. And it so happens that iFix supports data, so you can create reports. And the report is just a series of blocks that Win911 queries at the time that you request them. And when we get all of the data back, we send it on to the end user. So we'll call this report number 1. Building number 2. And I'll have to add some items. And I want my hoppers and my chiller. These are data. These are data items. If I want to include alarm information in the report, I just tab over here and click those as well. And now, if I have a smartphone with a mobile app, I can open it up and look at my reports, and there I would see building number 2. And if I tapped on that, it would query all these data points, hopefully in a timely fashion, and bring back my report for me. And that is the basics of iFix.
Awesome. Well, thanks, Mike, for joining us. And if you guys have any questions, concerns, comments, feel free to give us a call or email us. We are here to help. Again, any questions, comments, concerns, get a hold of us and we'll be able to help you out. Thanks for tuning in, and we'll have another one out for you soon. Thanks, everybody.